Hi all. Today we continue to study chapter 2 about motion. Last time we learned the gravitational law developed by Newton in the year 1687. This law tells us every object in the universe attracts every other object with a force proportional to both of their masses and inversely proportional to the square of the distance between them. Expressing it as a formula, we have Fg equals big G times m1 m2 divided by r squared. Here big G is called the gravitational constant, equals to 6.67 times 10 to the negative 11 Newton meter square per kilogram square. It is a universal constant. Newton developed this law in terms of the Kepler's third law and the centripetal force of circular motion. Gravity on the Earth by the Sun is equal to the centripetal force for the Earth to revolve around the Sun, approximately along a circle path. Replacing the speed of the Earth by the circle perimeter divided by the period. Applying the Kepler's third law, one can derive, as Newton did in 1687, the gravitational law. Fg equals Gm, big M over r squared. Here we give some examples. The first example applies the gravitational law to determine the gravity between two objects of 5 kg and 10 kg, with distance apart by 5 meters. We first write the gravitational law formula, then substituting the gravitational constant G and numbers for masses and distance into the formula, we obtain the force, the gravitational force between the two objects, equal to 1.334 times 10 to the negative 10 Newton. Another example is to determine the mass of the Earth. Considering the weight of an object on the Earth is the gravity on the object by the Earth. We have the mass of the Earth equal to the gravitational acceleration times the square of Earth's radius divided by the gravitational constant. Then substituting 9.8 into the little g, gravitational acceleration. And the Earth's radius r as 6,400,000 kilometer, 6,400,000 meter, and also the bigger G, gravitational constant, into the formula. We can find the Earth's mass approximately as 6 times 10 to 24 kilograms. The last section of this chapter is about the satellite motion. It is a circular motion, and the centripetal force is the Earth's gravity. For low Earth orbits, the height of satellite above the ground, h, is negligible in comparison with the Earth's radius, big R, which is 6,400,000 meters. In this case, we can determine the orbital speed based on the gravity to be the centripetal force as the square root of little g, gravitational constant, or gravitational acceleration constant, times the Earth's radius. which is equal to about 7.9 kilometer per second. So the orbital speed is 7.9 kilometer per second. The speed required for an object to escape from the Earth is called escape speed. Like a NASA want to send a space shuttle to the Mars, for example. They need first to escape from the Earth. Escape speed is equal to the square root of 2 times the orbital speed, the 2gr square root, which is equal to 11.2 kilometer per second. We don't go to detail about how to derive this escape speed. This basically using the energy conservation. We will learn energy in the next chapter. So we just give the result, what the escape speed, what the value it is. That's it. All right, thank you. That's the end of this chapter 2 about the motion. So we learned how to describe motion and Newton's 3 laws about the motion, and then gravitational law, okay, the circular motion also. Thank you.